Hello again, everybody, and good morning from me once again. I'd like to welcome you all back for the next keynote panel. So I think this session is got really great lineup, really interesting and very hot topic, which we spoke about briefly in the morning panel. So we'll be talking all things dynamic containment. I'd just like to give a quick thank you to Arenko Group and SAFT, who are our sponsors for this session. And we have our moderator, who is Lauren, one of our analysts from Solar Media, who's very knowledgeable in the UK market. So without further ado, I'll hand over to Lauren. And as my colleague said, feel free to ask as many questions throughout the hour-long session and we'll get them all answered. Over to you, Lauren.
Thanks, Lucy, and thank you everyone for joining our session this morning on dynamic containment and beyond. We have just under 1 hour for this session, so the first half will be a discussion and an opportunity for the panellists to share their perspectives on the topic. And in the second half, we will answer audience questions. So please submit your questions as we go along, and we will get to as many as possible at the end. So to kick things off, I would like to invite the panellists to introduce themselves. And so first of all, I can hand over to Faye.
Thanks, Lauren. Hi, everyone. I'm Faye Relton. I'm responsible for delivering frequency response reform in National Grid ESO. Recently, me and my team led the delivery of dynamic containment in the autumn. And we're also responsible, my team are responsible for the weekly frequency response auction trial, which closes at the end of November this year.
Thanks. And now Devrim.
Devrim Celal, Chief Executive of Upside Energy, which is now part of Octopus Energy's software licensing business known as Kraken Technologies.
Thanks. And now Mike.
Hi, so Mike Ryan, I'm UK Commercial Director for Habitat Energy. Habitat Energy provide algorithmic route to market services for batteries and other flexible tech.
Thanks. And Roger?
Hello, my name is Roger Hollies. I'm the CTO at Arenko. We started Arenko back in 2015, around the same time as the photo for this session was taken, the one that's been used. So as you can see, along with my hair, lots changed. Yeah, we've been developing software and hardware combinations since 2015-16 with a dedicated focus of bringing these flexible assets into exciting new markets like dynamic containment. We've been in dynamic containment since day one on the roller coaster ride with the other providers and the ESO themselves. And we're currently focused on bringing more assets in and evolving the markets into their future state that they're going to be. It's a really exciting time. Hopefully going to get into some of the detail of it now of why it's so exciting. Very excited to be here. Thanks for inviting me.
Thanks, Roger. And Michael?
Yes, good morning. My name is Michael Lippert. I'm working for SAFT, who is a France-based and worldwide operating developer and manufacturer of battery systems. I'm working for the ESS division, so Energy Storage Systems, which is one of our major and developing activities in charge of innovation and more long-term marketing activities. I'm also having different hats in Brussels. In particular, I'm Vice President of the European Association for Storage of Energy, and I'm chairing the ETIP, which is a technology platform for batteries in Brussels.
Thanks. And finally, Robin.
Good morning. My name's Robin Redfern. I work with Everoze Partners, where I've been working in storage since 2016. Cover quite a few areas: owners engineering, due diligence, that sort of thing. But most relevant to today is the work that myself and the wider team have been doing since the days of EFR, FFR, and now specifically dynamic containment in providing test verification as the role of independent technical expert. So that's sort of the specific element that I'll bring along to today's panel.
Great, thank you. So to start with, I want to talk to the panelists about what is dynamic containment and how is battery storage participating. So first of all, I'd like to go to Faye. Could you give us a top-level overview and a short introduction to dynamic containment?
I can, yeah, that's fine. I'll just talk a little bit first about why we need dynamic containment and why we're bringing in new response services in National Grid ESO. So one of the key parts of GB's power system is stability, and frequency is key to stabilising the system. The entire network operates at a frequency of 50 hertz. Just a slight deviation from that can impact assets and the infrastructure. So a key part of our role as National Grid ESO is to maintain a stable system frequency. The amount of frequency response needed is directly influenced by system inertia and the size of the largest generation or demand loss. Talking about system inertia, the need is greatest when inertia is low on the system, because frequency moves faster when inertia is lower. We're seeing the growth of renewables on the system, and with that we observe a consequential decrease in system inertia, especially at times of low demand and high renewable production. And that's going to continue as we move towards our zero carbon ambition 2025. So as a result, one of our key priorities is to bring in new faster acting frequency response services, and Dynamic Containment is the first of our 3 set of frequency response services that we're bringing in. So there's DC Dynamic Containment, there's Dynamic Regulation, DR, and Dynamic Moderation, DM. I'm happy to chat about those are the 2 products later on in the conversation. So we launched DC in the autumn last year, 1st of October, as a soft launch. So kind of a trialing and learn by doing approach, both for us and for industry, as I'm sure we'll get into shortly. We also introduced daily procurement, which is a huge step towards procuring closer to real time, and really proud of the team for bringing that milestone ahead. We were meant to be delivering that early this summer, so I'm really proud of the team for bringing that ahead of schedule in our forward plan. There's more work to do on DC with the soft launch. There's further development, further engagement. We've just closed off a consultation and had approval from Ofgem, so that there's some changes that are going to be implemented, I think, first week in March. So I'm really excited to see those, and also really looking forward to engaging with industry on the other 2 services, DM and DR, and that should start early spring. Hope that's enough to kind of start the conversation. Happy to take questions as and when.
Thanks, Faye. That's a great overview. So if I could go to Devrim next, maybe you could say a little bit about how dynamic containment is procured and what type of companies are currently participating.
So I think, Faye touched a little bit of this, so I'm not gonna double up on that. But a little bit of what excites me about dynamic containment, because I think it's truly the first digital solution that's come out of as a service from National Grid. It's not one of the past ones where you can park a heavy controller at the site and preset conditions to deliver. It has to be interactive with the system and provide data back and forth. And that's where sort of Upside fits quite nicely, because we are a pure software platform. We don't develop our own batteries, we don't trade. We just provide that capability to asset owners and traders to interact with each other and to manage services like this. Now, with dynamic containment, there's been a little bit of a background noise, and I love the way National Grid approached this with a very agile methodology of throwing something out there, seeing how it works, modifying and improving over time. And that fits us quite well. And it also helped that at the beginning, there was only about 3 of us providing dynamic containment, roughly around 139 megawatts of power. But over time, that's increased. And that's partly because of the nature of the service. It's extremely precise. It requires data sampling rates that's have never been tested before at 20 hertz. And it gives you a very narrow margin of error when you're delivering it. And that sort of, I think, is being reflected on how slowly it's starting to ramp up. So initially, we got 3 big assets out there delivering it, proving that it actually worked. And now we're seeing increasingly more and more players come to the market. I believe at the last procurement, there was about 9 different players. And that's a nature of the physical aspect. Now, we're very good at managing the digital aspect. There's a service criteria. You design a digital service to deliver that. And then you have algorithms that refine and make that even better. But when you hit the physical world, you start getting into real constraints and stakeholder management. And what you discover when you get to some of the older assets is they were never designed to deliver a service like dynamic containment. They were perfect at frequency response, but when it comes to dynamic containment, they need a little bit of a physical upgrade. And when you're going through that process, you are involved the asset owner, the O&M provider. You get Robin to come on board and look at your test results. but also you need the DNO's participation, and getting all this complex stakeholder management takes time. And once you get to the site, you're testing a completely new service, you want to try out different solutions. You want to try out a frequency meter that can sample at 20 hertz and a power meter. And as a result of this, it's taken some of the older sites that were built 4 years ago, 5 years ago, a little bit longer to get the fitting solutions. But what I expect in the next weeks, and I know that from our own pipeline, we're going to have quite a few sites coming on board. And just to give you a flavor, because we are the middle ground, we got multiple traders and asset owners working through our platform. Currently, we have just short of 0.5 gigawatt of batteries contracted on the platform. And with renewables, just over 0.5 gigawatt. So you could expect to see almost all of those devices providing either dynamic containment or the new services as they come further down the line.
Great, thank you. And it certainly sounds like there are a lot of opportunities there for battery storage. So Mike, if I could come to you now, could you say a little bit more about those opportunities and some of the revenue potential from dynamic containment for batteries?
Yeah, sure. Thanks, Lauren. So, I mean, it's almost a bit blasé to say, isn't it? But clearly one of the things that's attracting all asset owners into this market is the revenue they can earn from it. Right now, as Devrim's highlighted incredibly clearly, there's a shortage of providers versus the volume of DC that National Grid are looking to procure throughout the summer, leading to what are comparatively very high prices compared to other services you can take part in the majority of the time. So assets are currently earning about £17 per megawatt per hour in this service. So clearly consistently outstrips anything else out there. It doesn't always. There are days when you can earn greater revenue through merchant trading, but that's, dare I say it, in some cases, even more difficult to do than dynamic containment. Dynamic containment has quite a high barrier to entry. You need to pass these technical sign-offs to be able to deliver it. You need to have the right systems in place. But once you've got them, it's then relatively easy to deliver. So that's why we're seeing lots of people jump into it. I think that value is going to start coming down, and it will come down surprisingly quickly when it starts falling. If people remember what happened to FFR prices in the FFR market, once that was saturated, there's absolutely no reason to believe the same thing won't happen again with DC once we get big volumes in there. One thing that might delay that a little bit is obviously what's happened is a lot of assets that were in FFR have transferred across to DC. So actually we need DC and FFR volumes to saturate before we see both markets come down. People will have noticed that FFR revenues have increased because volumes have transferred to DC. There's now a shortage of supply in FFR. So even if your batteries haven't been able to participate in DC yet, they've probably seen some element of the uplift. The other great opportunity in DC at the moment is the ability to stack with the BM. Right now, because DC is a one-directional service, you have basically the entire import capability of your battery able to offer up into the BM. Again, some technical challenges in being able to do that, but ones we've now seen multiple assets managed to overcome, and there's no reason to believe that others won't be able to get there. Then the opportunity really comes down to, well, how good are you at playing in the BM? How good are you at earning that revenue and offering yourself up to National Grid to be utilised at, not say a maximum rate, but a way that ensures you're generating maximum revenue. What we'll end up seeing is all of these, in my mind, will just converge towards the opportunity cost of delivering merchant trading. So you're just going to price in, your asset to National Grid almost like an option. You're saying, well, if you want to use my asset for delivering dynamic containment, that's fine, but I could earn whatever it may be, 10, 15, 20 pounds a megawatt per hour if I trade it myself. So National Grid, if you want it for DC, that's what you have to pay. And if you're not willing to pay that, that's absolutely fine. It means National Grid doesn't value it that highly, but you can go away and earn that revenue in merchant. Basically, the opportunity means that there's going to be multiple revenue streams out there, multiple ways to earn value from your asset. You just need to be able to dynamically switch between them rapidly, and you need to be able to truly and accurately forecast the opportunity cost of each of those revenue streams.
Great, thank you. So we've heard a lot about how many opportunities there are and some examples. So maybe Roger, if you could say a little bit about why batteries are so well suited to providing DC. Roger, you're muted.
Classic, apologies. Yeah, thanks for that, Lauren. Yeah, I think batteries, the dynamic containment service is a post-fault service, as Faye said. So it needs to be responded to very quickly and very accurately. And the testing regime that National Grid have put in place is designed to ensure that the assets are delivering this are very good assets that can deliver this service at scale, so they can trust this service. Batteries inherently are very, very fast. They're electronically power controlled, and you can control that waveform very, very accurately and very, very quickly. Now, whilst it has got quite high standards, this service, it's by no means difficult for a battery asset. We're having to slow down the assets that we've entered into the market between 200 and 300 milliseconds each. And actually the difficulty is having the controls. So the battery assets can deliver the service and quite a lot more. And I'll come on to that in a moment. But the key point to this is the control side of it, and being able to slow it down and being able to meet the requirements of this non-linear response. So there's a very shallow initial response to frequency, and that steepens up towards the end when you're in a post-fault situation to get a lot of power onto the grid when it needs it. So the key thing is it's got to be software controlled and digitally controlled, as Devrim said. And companies, I think, like the ones that are in this panel, have all invested heavily into the software control, the digitization of the assets. And I think that one of the reasons we're seeing this slow uptake, as Devrim said, is because I think some assets just are pre-contracted, but some assets just do not have this control layer on them that is going to put them capable of doing these services. And it's important to think, it's not the first stage is to be able to do dynamic containment. The next stage, and to help us move forward and deliver these and more services, is looking forward at the future markets and making sure that your control systems are capable not just for the services now, but for the services in the future. And we've only just really scratched the surface. And one of the things I like, and I think it's been mentioned already, is this service is the first service that's really starting to expose the capability of digitally controlled assets, and of which batteries are going to become a predominant part in the short term. We're not even touching the rest of the capabilities. These systems can deliver reactive power, they can deliver faster services, and they can deliver energy services as well as power services at the same time without impacting either of delivery of the service. So already we've seen National Grid evolving the service and allowing you to be able to stack multiple services. And if you've got a digitally defined asset and a software controlled asset, as long as you can split up the data streams, and there's quite a lot of data, there's like 17 million points per day, which is a lot of data in the energy industry, but not a lot of data in the software kind of world. But once you're able to then start stacking these revenues, you're also then able to offer them at a lower cost. There's going to be more competition, but importantly, stacking them gives you alternatives. So the batteries are not just going to be beholden to a crashing dynamic containment price. I don't think it's going to crash that severely, because there are alternative markets, much deeper markets, that are going to offer a stable alternative price. And this is all about alternative pricing. Dynamic containment's cheaper than National Grid's current technical solutions. So, and as that price comes down, it'll be better for the consumer because costs will come down. And then alternative markets that batteries and other technologies can move into will further help evolve and hold these prices. And it's eventually, hopefully, give us a low carbon system that is really good value for the consumer. So batteries are really fast, really capable. And I think we're just scratching the surface of what they're capable of doing.
Great, thanks, Roger. And we've heard a lot on the software and the digital control side. So I'd like to go to Michael now to hear about the challenges that DC presents from a battery technology perspective.
Yes, thank you, Lauren. Well, from a point of view of a battery manufacturer, Of course, there are always challenges linked to any service, in particular questions like response time, as mentioned already, and the physical device, as we said, can do it, but there's the issue about the control level and in particular also the speed of data acquisition is a challenge in this particular field. Beyond this, of course, we have the challenge to have a very high and guaranteed level of availability. So to minimize questions of downtime and maintenance, we need to look at a high energy efficiency, which is not only the electrochemistry, but in particular the energy you need to for heating and cooling and overall auxiliaries and safety. So these challenges we face basically all the time. Now, what is specific about future markets, the DC and more globally, is the fact that, well, as it says, the operation pattern of the battery as such is a function of the frequency. And it means we do not know exactly how a battery operates in the short term and in particular on the longer term. By definition, as the battery, the frequency is an expression of instabilities or unbalancing of the system. It will certainly change over time. So how will the frequency behave and how does the battery need to respond to this? There is a factor of unknown operation pattern. More importantly, even, we know that a single battery will not respond to a single service. I mean, it will certainly do will certainly do a DC, but as we already said, we are talking about service stacking. A battery will do different services, and this combination of services may be one type of typical operation today. It will change in 3 years and in 5 and even in 10 years over time. So one of the major challenges here in making a battery and in managing the battery is how do we anticipate its capability to respond to different operation patterns in the future. Now, of course, we do build in a certain level of flexibilities in the capability, and what a battery can provide is not only just a question of its power rating and its energy. Of course, we need to look at, to take the power, is it available all the time throughout its state of charge? How will the power evolve over the lifetime? So this has to do with impedance aging. And globally, what is the aging pattern of the battery in a certain circumstances, and how do we manage the thermal homogeneity within the battery? So saying a battery is able to provide a certain service is more than just power and energy. It is managing the entire system, and we, of course, we need to anticipate, and we do anticipate a certain flexibility in this respect. But we cannot do a battery that is simply able to do any kind of service. So the more important thing here is that we are able to know and to anticipate very precisely how the battery behaves under possibly different operating patterns. To give you an example, this is what we have done with Total in France. You know, Total is about to deploy more than 100 megawatt of FCR and end capacity services. So it's a multi-pattern. And we have simulated different operation patterns in terms of battery behavior, degradation mechanisms. And with this, then we have given to the operator the tools to use in the most effective way the battery, to measure its opportunity cost if we use it in a more intensive way or in a less intensive way, and depending then on markets and pricing systems, to best use the battery in the most economic and efficient way. So this is one of the answers. It is about giving the battery some flexibility, but in particular knowing and being able to modelize different operation patterns. Looking a little bit forward, of course, there are other tools and ways we can deploy, and we do deploy to answer to this level of uncertainty and evolving requirements. for example, changing the energy to power ratio over time. So to adding energy, in particular in the UK, where we anticipate that still very much short-term oriented, there will be more energy required in the future. But as you don't know exactly how to anticipate this for a 5 or 10 years lifetime, we may simply add capacity over a time. So you need a control system and an architecture that enables this. And the last point is, of course, but it's not a technology thing here. It is to provide flexible guarantees, take into account these different operation patterns, and to adapt together with your customer operator to evolving market conditions.
Great, thanks, Michael. And kind of touching on those points around flexibility and providing different services, I'd just like to go to Devrim. Maybe you could say a little bit about the challenges around providing different services and the stacking that we've seen.
Yeah, of course. Just to recap, I think I love this conversation about digitization of energy. It's finally there, and I think if you're going to get to a carbon neutral grid, it's absolutely essential. But the few things that dynamic containment brought is, one is that extreme accuracy of the service delivery. The second one we all discussed, it's the amount of data and the frequency of sampling data. The first thing that Roger mentioned is actually having to slow the asset down, to reel it in, to respond based on a certain profile. But the next thing is the baselining. And I think some of your challenges come around when you're trying to stack things is baselining it properly and being intelligent about that, so that you use that very low ramp rates that the service provides you to always think forward and make sure you're using those small interventions to position the battery in a place to maximize the benefits of stacking revenues further down the line. So that's one complexity of that. So you need to have a really good baselining algorithm that takes that into account. The second part is making sure that you're respecting the operational performance of the asset, so that you're positioning the asset and using it within those parameters to make sure that you are extending the life of the asset as well. Now, where we like to see, and Mike talked about this as the option value of national grid. So you put your option price down. If it strikes, you play in that game. If it doesn't strike, you go and play in different markets. And it's almost like that's a good method. But if you get into a market and then you see there was a bigger opportunity elsewhere, you're almost stuck in your lane, looking at the other one and saying, I wish I was in that second lane where we could have had a much better return. So it would be an even better opportunity if the procurement went from day ahead to real time in the future, where you have the ability to, or the traders have the ability to start playing this optimization game, not just as a day ahead option play, but also looking at that in the shorter term and constantly looking to shift lanes to always maximize the potential return.
Great, thank you. So I'd like to bring Robin in now. You've been mentioned a couple of times with regards to testing. So could you tell us about the testing required for a battery to provide dynamic containment?
Thanks, Lauren, and thanks to those earlier. The £20 that will be in the post, Devrim. As soon as I get off this panel. Yeah. So really, to summarise, I think we see two main challenges from the testing side, and the first we've already heard a lot about, the accuracy, the precision that's required here, and that batteries can meet. And one of the real parts to that, I think, is measurement quality. Really, the whole chain of measurement needs to be well designed and engineered to be able to provide the level of quality that's necessary. In particular, I talk about frequency measurement. Power is important, and we need to measure that to prove the testing, but actually it's generally the frequency that's the trickier bit to get right. And just to take a step back here, frequency, unlike current or voltage or power, is not an instantaneous value. Frequency, as we all know, is something that's varying all the time. By its very definition, it's a waveform. So it takes time to measure it accurately, especially when there's noise, when there's harmonics, and there's all sorts of other bits and pieces going on. So to try and measure that frequency accurately, and within a short time scale, and to provide the data at 20 hertz is quite a challenge for several projects. It's by no means a barrier. We've seen plenty of projects doing it very well, but it is a real challenge. And I think it's connected to the fact that we need high accuracy, not just because dynamic containment requires high accuracy provision, but also because it's so closely linked with power. So if you mismeasure frequency, even very briefly, your power that comes from your project will respond very briefly, but potentially quite significantly because it's so sensitive. We're talking about very small changes in frequency here that these devices are designed to pick up on. And so really the first message I would have is think very carefully about frequency measurement devices and the full chain of measurement that leads to those. The second sort of key point that I think really comes up during testing is speed of response. And again, as Roger has clearly said, this is very achievable for batteries. It's what batteries are good at. You can turn them on very, very quickly and ramp them up very quickly. But it still requires a bit of consideration from those designing and testing these projects. And I see it as really, speed of response is separated into two bits. There's the first bit, which is measurement time, working out what the frequency is. Already spoken about that a little bit, potentially filtering that frequency or averaging it over a longer period to make sure you've got a really stable and reliable number. And then working out from that what the new power set point needs to be. And it has to do this obviously very quickly. And then the second part is once we've got that set point, it's for the project, in this case, usually the inverters or the PCSs, to ramp up to that new set point. So there's two quite discrete bits. And I think most operators will have a reasonable amount of control over the latter, over the former bit, sorry, the time to measure, the computational time to work out a power set point, but they'll have a lot less control over the second bit, the ramping time, because usually that's intrinsic to within the manufacturer's inverters or PCSs or what you want to call them. And so really it's tweaking that upfront bit, perhaps adding a delay if necessary, speeding it up by changing how you're doing it if necessary, that are under most people's control. And that again requires some time and some challenges. Perfectly doable, but that's the key element. And it's another good reason for installing a good quality chain of measurement.
Thanks, Robin. And it certainly sounds like there's a lot of things to take into account when designing and planning these new systems. So I'd like to go to Mike. Maybe you could kind of give some comments on things that developers should be thinking about when planning batteries now in order for them to participate in DC and also future markets.
Yeah, and I hope I now just don't ask for all the things that Michael said. It's really hard for a battery developer or a cell producer to do. Like, I want something that's ultimately flexible. I want it to be able to deliver really high power services, and I want it to be able to deliver really high energy services as well. And obviously assets can't do that. So you are looking for flexibility where you can find it, but you're never going to get an asset that can be all things to every service. May even be the potential in the future that perhaps some assets get really niche on being high power assets, and some become more suited for energy delivery. For me, what's key is making sure when you're getting that asset that the warranty is really well scoped. And what I mean by that isn't just that it lets you do whatever you want with the battery. You're never going to have that. But you've got a warranty that details clearly and well exactly what the impact is on the asset of operating it in one of any number of ways. So what we want to know is exactly how does the battery degrade if you operate it in DC for a certain period of time? How does it degrade if you're operating it doing several high power arbitrage cycles? And the more detailed we can be on that, the easier it is for us then as a trading function to convert that degradation warranty into value. And if we can convert it into value, we can then say, okay, this action I'm about to take is highly degradative of the battery, but I'm going to earn so much value out of what I'm about to do that is the right economic thing to do. It's not always about trying to preserve the life of the asset as long as possible. It's trying to make sure that you earn as much value as you can over the life of the asset. And it may be that you earn, very unlikely at the moment, but it may be that you earn more value by using the asset intensively, earning lots of value and degrading it over a period of 5 years. It might be that it's better to degrade it very slowly over a period of 10, 11, 12 years and earn less value in each individual year. But we need to really understand what's happening inside the asset to be able to make that economic judgment call. Without that data, it's almost impossible to do. So I think that's key. And then the other comment, I think Roger, Devrim, Robin have already spoken at length about, it's about the control system that's there. You need a control system that really does give you access to the asset, that lets you treat it as flexibly as possible. We don't want necessarily, if you have a 50 megawatt battery, there could well be times where we don't want the entire 50 megawatts in DC. Maybe we want to put 40 in, maybe we want to put 20 in. Maybe we want it asymmetric. We want more on the high frequency side than we do on the low frequency side when that happens. So it's being able not just to treat the asset as one block, but to be able to break it down. And you almost end up hedging your revenue streams internally within the asset itself, saying, actually, I will leave some to wholesale markets and I will put some into ancillary services. So for me, it's really understanding the asset and how it degrades under various operating scenarios and being able to flexibly access the capability of that asset in all that means.
Thanks, Mike. And then going over to Michael from a battery supplier perspective, maybe if you could just discuss how battery suppliers can help with some of those concerns and future-proofing batteries going forward.
Yes, for sure. I think a common point we have heard in all the contributions so far is we are clear it's about digitalization and data. And this is the way we are going along. What we do and have done, and it's kind of state of the art, of course, is to have a good data acquisition on the physical device, again, which is not only cells and modules, it includes all the subsystems, the relation between the operation and the safety, for example, the operation, aging and temperature, and so on. So all this needs data acquisition. And monitoring. It needs to be entered into good models. To answer to Mike, yes, I totally agree. You need to know if I operate the battery in one way, what will be the predicted aging mechanism, how fast will it age? And again, aging is not only capacity loss, it is also impedance aging. So it's quite complex things. And so, but these are things we do today. I think in the future, what we will do even more so is, of course, to have this data on the cloud and then do data mining with it. What we are working on is to use this huge amount of both application system data, modeling data, in order to help our customers to even improve the usage of their asset. Whether it be in subjects like maintenance, for example, predictive maintenance, reduction of maintenance, so to really maximize the uptime. I mentioned earlier, availability is a key requirement, or even more so to use to optimize the operation pattern versus lifetime. Or to anticipate things like augmentation, capacity extension, or any change of parameters, again, in order to optimize the battery. If you have the data, if you have the right algorithms in place, then you can your customer, the operator with this kind of data. But these are things we are working on, so we are not yet exactly and entirely there. But as you ask about what are the future perspectives, that's where they are in my mind. And they all go back to the fact of having a very good understanding and control of the entire part of your storage device, which goes from the electrochemistry to the controls, the DC part, but also, of course, the AC part of your system. So you have to look at the entire components of a complete energy storage device.
Great, thanks, Michael. And I'd like to go back to Robin now. We've talked a lot about the larger standalone battery projects, but what opportunities are there for smaller projects to access the market, and what are some of the challenges there?
Thanks, Lauren. A good question, and it's always going to be more complex and therefore probably more difficult to get a lot of smaller assets, you know, whether that's domestic level or I&C or what have you, to work together on a high performing type service like this. It's always going to mean that if you have lots of small assets, you're going to need lots of meters, lots of control systems, and obviously that starts to get tough from a cost perspective. I think it is, well, actually, we've seen this being done in FFR. So there's good evidence to know that it can be done, and that's very encouraging. Great to have the sort of dispersity, I don't even know if that's a word, but you know what I mean, of assets right around the country. And actually, that's one of the things that National Grid is trying to seek with this service and others, is to have assets spread all over the place. So as if there is a major fault on the grid, you don't lose the assets that are actually providing the service to you. I think there is scope in the future to think and talk more about the benefits of aggregating data sets. So if you consider just one asset on its own, which has, you know, below specification data resolution, accuracy, then it is indeed very tough to meet the needs of this service. But if you start adding together hundreds or even thousands of separate assets, there are some benefits that you get from aggregating all of those data sets together. And it's actually something we're supporting WPD with in the Future Flex work at the moment, which I know EDF, Kaluza, Ecotricity, Octopus actually are participants in, is looking at aggregating data sets in that instance for DSO services, to see what improvements you can get by sticking lots of lower quality data sets together to create higher quality single aggregated units. So I think there's some way to go there, but I think it's still, some challenges are still around that.
Great, thanks, Robin. And just a quick reminder, if anyone in the audience has any questions, you can submit those into the Q&A feature, and we'll try and answer those for you. So we've got a question from the audience here regarding the convergence between wholesale markets and ancillary services. And does the option value take account of the impact on degradation, cost or provision of these services? Are some assets better suited to one service or another, and will niche operators emerge, or is it always about stacking? Does anyone have any comments there?
Yeah, I can. Oh, sorry, Roger. So yeah, you know, will they converge? I know I said earlier, yes, they'll converge. I probably use that term a little bit loosely. Clearly, there's going to be a dependency here on the cost of delivery, essentially, and that cost of delivery is both any energy you need to procure to deliver the service, but also the impact it's having on the asset. So something like DC with very low levels of cycling is actually very light on the asset. So interestingly, that means your cost of delivery is very low. Therefore, actually, the price there could drop lower than the opportunity cost of merchant, because you'd be willing to deliver that at a lower cost. I think also it could drop lower because despite everybody making great efforts, and despite, I'm sure, Devrim trying to sign up everybody he can to upside services, there are probably some providers who will struggle ultimately to get into it, either because they're locked into long-term contracts with you know, other route to markets and other control systems. They just won't be able to get there. So I do think we're going to see this period where there'll be people in FFR and people in DC who have a low cost of delivery when they're in, aren't partnered with the right people who can earn the merchant revenue so don't have as high an opportunity cost. And actually, throw some credit Roger's way here, it's probably people with ourselves and the likes of Roger's company who will drop out of DC first because our opportunity costs are higher. We can go and earn more revenue elsewhere. And I think that's what you're going to see happen. I think ancillary services will drop below the opportunity cost, or the opportunity cost for the likes of us of delivering merchant.
Thanks. And Roger, did you have something to add there?
Yeah, I think it's what's really interesting is the operational costs are an opportunity in some cases. So we've already seen with the stacking of the BM plus the one-way dynamic containment. So one way, we're just delivering power into the grid, and therefore we have to top up our power to top up our energy in order to carry on delivering, hold our state of charge. Now we've already seen by being available in the BM that we're getting negative prices. We're getting paid to take energy off the grid because we're flexible enough and we have the control system and we're integrated with the balancing mechanism and the other markets. If they go to negative prices, that requirement to rebalance actually becomes an opportunity. We always talk about the assets as always being capable. Even if they're full, they're capable of discharging. Even when they're empty, they're capable of charging. Both those requirements are critical in a low carbon system moving forward. Sometimes we're going to have too much energy on the grid and it's got to go somewhere. So, and it can be cheaper. And it's always, whenever we get paid to charge our battery, it's because we are at a lower price than paying the wind turbines to turn off. So it's a double bubble there. We're generating revenue from taking this energy and then using it to rebalance the system later on. The grid is getting that service at a lower price than turning the wind turbines off, and we're facilitating low carbon power into the grid. It's this kind of combination of thinking, and the companies who are investing heavily in their software to be thinking about these services. Like dynamic containment is easy. I've been quoted as saying that it's pretty brutal. Some aspects of the testing were pretty brutal. That's been addressed. Moving forward now, at the moment, dynamic containment is really easy on the assets. The cycling is really low. The speed of response is well within capability. The tricky part is what's happening in 5 years' time, how these different services are going to interact and being able to stack those revenues up, working with the technology providers to make sure the assets are capable of doing these things into the future over the kind of 10 years of lifetime. So I think it's really exciting that one man's cost is another man's opportunity, and to get the low carbon and low cost system that we all want in the future with affordable low cost energy and low carbon energy for all is going to require this continued investment into the technologies. I think it's just extremely exciting to talk about how these things are all going to intertwine.
Thanks, Roger. And we've had another question here, which is, can National Grid expand on the future DM and DR projects mentioned earlier? And how do they differ from DC, and when can they expect it to be operational?
Of course. So we're going to be designing the products similar to how we did with DC, talking to people to understanding what's possible, what we need to do. So we haven't got a set of 2 shiny products ready to roll out. So what I do know though, so moderation, dynamic moderation keeps frequency within operational limits, whereas DC keeps frequency within statutory limits. So providers of DM will help to keep manage sudden large imbalances by responding quickly when frequency moves towards the edge of the operational range. Regulation, that corrects continuous but small deviations in frequency. So providers don't need to respond as quickly as with DC and DM, but they have to have a duration that supports continuous operation. So that's as much as I know at the moment with the services. There's modelling that we need to kind of refresh and review internally to make sure we're clear on our operational needs so we can explain it and talk it through with industry, and then comes developing the service terms. So I can't tell you when we'll deliver, but I can tell you I'm keen to start engaging on DM and DR ASAP. There's some like I said, some internal modelling that we need to get the teams to do first, but we've already got some information out there about DM and DR in the response and reserve roadmap that we published in 2019. I'm quite keen to just start those conversations and hear what people think about what we've already shared. And then will come the output from the modelling, and then we can start looking at the service terms. I'd like to be in a position where we're procuring both of those new services by March next year. I think that's a reasonable timeline. I've learnt with DC, we had to get it in quickly from an operational perspective, but providers need time, and we need to engage more and give people more time to kind of understand the terms. So that was our learning from the soft launch. I think we'll be going for another soft launch approach for DM and DR, because I know the control room have really appreciated having that time. It's like there's a limit on how much we bought. They could see how DC kind of interacted with their existing toolkit. We would like to do the same with DM and DR. So it'll be a slow burner, but yeah, engagement starting soon. I'd like to be in a position where we're procuring it early next year, and it'll all be day ahead. So there's a whole thing about auctions and how we do that. And that is another very exciting but separate conversation that I'm happy to have at a certain point.
Great, thanks for the update. So we have another question here regarding data. So when speaking about aggregation of lower resolution data sets, are we speaking about greater or less than 15 minutes? Since most data has a 15-minute resolution if measured. And is there any more information anyone can share on that?
Do you want me to jump in on that one, Lauren?
Sounds good, Robin.
Yeah, so just to be absolutely clear, this isn't something that's necessarily being done when I was talking about smaller assets in dynamic containment just yet. So this, this is that final point I made was really speculation for the future. But in terms of data requirements for dynamic containment, that's all listed on National Grid's website, and we're talking 20 hertz data, so frequency and power at that sort of resolution, so substantially less than 15 minutes, and that's really necessary to see what these assets are doing in real time. So yeah, quite a lot faster than that.
Thanks, Robin.
I just add again. Oh, sorry, Devrim.
Go ahead, Roger.
Like 15-minute data, that is a very traditional kind of resolution of data. But with the Internet of Things revolution, 20 hertz data is not difficult. Like your mobile phone is capable of 20 hertz data, and there are plenty of those kicking around The digital revolution of all markets, and including the energy system, is going to bring one of the problems is it's going to be too much data for companies to handle. But the systems are in place. We're moving into a world where data is king, and handling that data and processing it and making it available and useful to users and to operators such as the ESO is going to be key. But this stuff, we landed on the moon 50 years ago. This stuff is not difficult at all. Go on, Devrim.
No, similar point. I think there's a hardware problem of measuring data at 20 hertz. That's one needs to be solved, because as you get smaller, it becomes not cost effective to install an expensive frequency meter, power meter every side. But I totally agree. Handling that volume of data is not a challenge. And I think we're obviously quite interested in enabling not just the very large assets that we focus on today, but also the very small assets, because what was the term? I can't remember the term you used, Robin, but handling the very high volume distributed model of assets, where you're creating resilience through the nature of just having so many that not all of them are going to fail at the same time. And then they're geographically distributed as well. Early days of frequency, I think we were one of the few, if not the only one, that demonstrated that you can actually manage dynamic firm frequency response purely from a cloud virtual control without any control required at each site. So you can imagine a world like that, where we're orchestrating hundreds of thousands of small batteries, electric vehicle chargers, heat pumps, all as a portfolio participating in maybe dynamic containment, maybe other services. So I think that's a future world that we need to conceive and take the regulatory steps now to enable participation in the future.
Thanks, Devrim. And we just have a moment left. So I'd just like to go back to Faye and just find out if there's anything additional in addition to the DM and DR question earlier that you'd like people listening to know about the plans for reserve and response reform going forward.
Yeah, this week I know that the team working on reserve reform are trying to they're trying to get a consultation out for Friday. Actually, it's looking very tight. So it's either going to be the end of this week or early next week. So reserve reform is also heating up, and there's going to be quite a lot of engagement coming with that. That's also expecting to deliver in March next year. So the next 12 months are going to be pretty busy for our team. There's the best place to keep an eye out is well, if you sign up to the Future of Balancing Services email subscription, I can, if anyone isn't involved and wants to be, just get in touch and I can send you a link. We send newsletters like weekly sometimes because it's all very busy, so it's a good place to keep updated. And then there's the Balancing Services website as well. But yeah, lots is going to be coming out in the next few weeks for response and reserve.
Great, thank you. Well, that's all we have time for now. So I'd like to thank all of the panelists for joining us today and for the excellent information. And I will hand back to Lucy.
Great, thank you, Lauren. Yeah, just to reiterate what Lauren said, thank you for the really great and informative discussion. And I think we've got some really, really exciting things ahead in the ancillary services market, that's for sure. So we'll wrap up here, and I just wanted to let everybody know that we do have a networking function running for the next hour. So you don't need to attend the entire hour, of course, but if you can jump in, then that would be great. It's just a speed networking session where you're able to connect with the 100 or so attendees logged on at the moment, and you'll be able to share contact details and have meetings, etc. But for now, I'll leave you to do that and also enjoy some lunch before we come back for EDF's presentation at 1:30. Thank you, everybody, and thanks to the audience. Bye-bye.
Thank you. Bye-bye.
Thank you.
Thanks, folks.
Thanks. Bye.
Thank you.